Hello everyone, myself Professor Tushar Gujrati from SND College of Engineering, Yeola. Today we'll study the experiment number 6 and the name of experiment is PID Controller. Okay, so let's start. So what is objective of experiment? Objective is to verify P plus I, P plus D, P plus I plus D control actions using PID controller. So as you know that there are three control actions are important. P means proportional, I means integral and D means derivative. Okay. So these control actions can be used independently or combined. Okay. So we need to understand these control actions carefully. So this is the objective of experiment. What is the outcome of experiment? Student must be able to explain the characteristics of various control actions like P plus I, P plus D, P plus I plus D. Okay. So after using such a control actions, what will be the characteristics of the instrument, that we will understand. Okay. So this is the outcome of the experiment. Now, what is PID controller? So PID controller consists of three controllers, that is P, I and D. Okay. So P means proportional, I means integral and D means derivative. So these control actions are selected properly and the output of this controller is given to the plant or process. Okay. So here in this diagram, this is the plant or process, this is to be controlled. Okay. So input to this plant is this PID network. Okay. Combination of P, I and D is the input to this plant. Okay. So suppose plant is operating. So in the plant some disturbances occurs. Okay. Because of these disturbances, the required output we don't get. Okay. So because of disturbances, the set point value and the measured value are different. Okay. So this generates error. So this error is given as an input to the controller. So error is given as an input to this controller. Okay. So control actions are directly proportional to error. Okay. So here you see the P term. So in the P term, the output is directly proportional to error, and P is nothing but constant of proportionality. So Kp into E, this is the proportionality. And in the second term, there is integration is done, integration of error is done. Okay, that's why there is constant is Ki is taken, and in the last term derivative, the derivative of error is taken. Okay, so like this, these three equations are there. So these three equations each have some advantages, some disadvantages. Okay, that's why they are all usually connected in together. Okay, they are not used separately. Many times they are used in together to achieve higher performance. So this is the graph, this we should get after using PID controls. Okay, so we'll study this graph later. Okay, first of all we will try to understand the procedure. So what is procedure here? Switch on, mains on switch. So first step is switch on, mains on switch, then switch on heater switch, enter PID controller tuning values as P equal to 50, I equal to 500, D equal to 1. So these values are called as tuning values. Tuning values means what? When we are using PID controller, at the time we have to enter values of constants P, I and D. So these values are like this: 50, 500, D equal to 1. Okay, and enter the set point as a required, that is 50, 60, 70 degrees Celsius. So now we are going to set one set point in the screen. Okay, enter the set point as required, 50, 60, 70 degree in PID controller using touch screen on the controller. So there are some buttons are available. So with help of those buttons we can set the set point. Let us assume 50 degrees Celsius. Now take PID controller in manual mode and keep output of PID controller at 50%. Okay. Now we can keep PID controller in manual mode. Okay, and output of PID controller at 50%. Now last point, when the process value reaches within range of plus or minus 10% of the set point, take the PID controller in atom mode and observe response. Okay, this is the last step. So when the process value reaches plus 10% of the set point, at the time we have to take PID controller in atom mode and observe the response. Okay, this is the procedure. Now this is the diagram of PID controller. So what is shown over here? Here we have shown one furnace. This is the furnace. This box is furnace. So inside this box, heater coil is placed. So this is heater coil, and also there is fan is also placed. So when we start heating coil, or when we give supply to heating coil, what happens? Temperature in the furnace increases. So this temperature is sensed by this RTD. RTD senses the temperature and gives it back to the PID controller. So this is PID controller. Okay. So PID controller has different buttons for setting values of P, I and D. So by using set point values, we can set the values of P, I, D. Okay. Also we can set the temperature in the furnace. So that is called as set point value that we can set. Suppose 50 degrees Celsius, we have set set point value in the furnace, and according to this and values of PID, the controller gives signal to the heater coil. Okay. So like this, control signal is given to heater coil. So like this, you understand, very simple working is there. We have to start the furnace. After starting furnace, what will happen? The temperature in the furnace will increase. So this temperature is sensed by RTD. RTD gives this signal to PID controller, and PID controller takes action according to the set point values and values of PID, and like this furnace temperature gets controlled. And after taking all the readings, if you want to cool down the furnace, at the time we require this air cooling fan. Okay, at the time we can go for air cooling fan. So observation table I have shown here. So what we have to do in observation table? First of all, we have to set the value in the controller. Set point value, suppose 50 degrees Celsius. Okay, 50 degrees Celsius we have set point value, and then we have to start the heater. So as we start the heater, what will happen? The temperature will rise. Okay, so this temperature we have to note down for, suppose we are using only P as a controller. At the time we have to note down the temperature will rise from 0, like suppose it will be 10, 20, 30, 40, 50. Okay, so like this temperature will rise, and for every 5 to 10 seconds, suppose for every 10 seconds we are going to note down the reading of temperature. So like this, for every 10 seconds we have to note down the temperature. So we are going to select different controllers. Suppose we are selecting P controller only, at the time value of I and D will be 0. If you are using only I, then value of P and D will be 0. When you are using only D, at the time P and I will be 0. Like this, you can use combination also P plus I, P plus D and P plus I plus D. Okay, so these readings you have to take separately. Okay, you have to separately select this controller and note down the readings for every 10 seconds. Then you select different controller, then note down 10 readings. Okay, like this you have to take the readings, and after taking reading you have to plot the graph. Okay, so first is temperature versus time. Okay, very simple, means when no controller is selected, at the time you have to draw the graph. After that, temperature using P versus time. When you are using only P, then temperature using I versus time, then D, then P plus I, P plus D, P plus I plus D. So you have to plot all the graphs. Okay, so that you are taking the reading. So all the readings you have to plot in the form of graphs, and you have to see the results. What are the observations from the graph? So usually these are the output of Kp, Ki and Kd, that is proportional, integral and derivative. Okay, suppose you are using only D type controller, at the time you will get such a output. Okay, so there are some Kd. Okay, so what is in Kd? So there are some peaks are observed, and after some peaks or oscillations you will get your output signal as a controlled. Okay, similarly in case of proportional you will get some one peak only, and then you will get controlled output. Okay, and in case of Ki integral you will get something like this graph, and then you will get controlled output. Okay, so like this, these are the graphs of different inputs Kp, Ki and Kd, and after taking combination you should get proper stable graph like this. Okay, so this is the response for step input. You can see that blue color line is nothing but step input, because here it is 1 is written. So this is step input is given. For this step input the graphs are shown as output. Okay, so like this you should get the graph from the observation table. So what is conclusion from this experiment? From observation table and graph, it is found that the temperature is controlled at set point value with PID controller when used in combination of all P, I and D. So from observation table and graph, it is found that temperature is controlled at set point value. Suppose we have set value is 50 degrees Celsius, then temperature is controlled at 50 degrees Celsius plus or minus 5 degrees Celsius, okay, with PID controller when used in combination of all PID. So base readings we get when we use all the three combinations together, PID, okay. So this is the conclusion. So thank you so much all of you for watching this video. So in this video we studied the experiment of PID controller. Thank you.